Hi! In this episode I'll take a closer look at Tanaka Contours. Most of the material comes from Anita Grass's blog, and I'll include links in the description, as well as any code I use in the video. The process is pretty straightforward. First you need a raster elevation layer, which you may clip to a suitable area in order to limit the processing needed. Then you create the contour lines, split them into segments, calculate the azimuth or orientation, and finally you style the layer with an expression. I already have a clipped elevation layer, so I can start by creating my contours. In the processing toolbox, you can search for contour to find the correct tool. I select the default values, which creates contour lines with 10 meter elevation intervals, since my elevation data is in meters. The next step is to split the contour lines into the smallest possible segments. That means lines with only 2 vertices. The process will create a layer with significantly more line objects. The next step is to calculate the azimuth or orientation of the short lines individually. This is done with a Python formula that calculates the azimuth from the line start point to the line end point. This will result in a value from -180 to 180. So for values below 0, I add 360 degrees. This will give me a value from 0 to 360 as my orientation value. In the advanced Python field calculator, I paste the code and make sure it follows Python syntax, especially regarding indentation. To style the layer and give the impression of lighting, I set the color with an expression. I use hue, saturation, lightness to set the color, and I only set the lightness value. This is supposed to be a value from 0 to 100, so I need to scale my azimuth or orientation value to that with a linear transformation. The next step is a bit harder to explain, but essentially I use an if statement to modify the azimuth so that the lighting will seem to come from the upper left or 45 degrees. And since it doesn't matter if the line goes from left to right or right to left, I use the absolute statement to convert the azimuth to a value between 0 and 180. This is the value that is scaled to the lightness value in the color statement. And that's it. You can play with the line thickness, etc., and it looks pretty nice with a styled elevation layer in the background. See you next time!